I'm a software developer at Jembi Health Systems, and I was in the team that built the OpenLHIM, or the Open Local Health Information Mediator. So I'm just going to tell you a little bit about why it exists and kind of how it works. Cool. So the purpose of the OpenLHIM was to grant online capabilities to a local system, Tier.net. So Tier.net is a system that's been deployed around the country that collects predominantly HIV and TB data. That system was built to be offline because a lot of rural clinics and that kind of thing in the country do not have any access to internet. That is slowly changing as things like LTE and satellite connections become more widely available. But for the most part, these kind of softwares are just offline only. And the original way of syncing data between the two is generally someone driving around with a USB, which is not the quickest or most efficient way to get data transferred around. So the idea with the OpenLHIM was to act as an intermediary to provide online capabilities to this system. So that's, they don't necessarily have to build those capabilities into Tier.net itself. So it allows, bidirectional syncing of data. So that data is generally lab results. And now we've actually added the upsyncing as well, which is some patient data, which is now going back up. And it uses the file system. So it's really just, it's pulling a bunch of data from a central place and then drop it on the file system, where the local system then can bring that in. Yeah, so one of the big things to consider with this is, if you have an offline system that you want to now give online capabilities to, the question is always like, it's a really question of resources. Does your dev team have the capacity to build online capabilities into your existing systems? Often because these are NGOs and there's funding issues and that kind of thing, there might not be a capacity to build to add online capabilities to your system. So this kind of system comes in quite handy in those situations. Cool. So the one thing about this is that it's designed for low resource settings. So as I said, in rural communities, both internet and electricity are not guaranteed. So you have to really design around that. So this is just a little service that just checks every 15 minutes to see if there is internet connectivity. And if there is, then it tries to download results. And one of the things we do, just to make it a little bit more fault tolerant, is we always download yesterday's results. So there is a slight lag time in getting results, but that means we always know that you're getting a complete results set. So you don't have to do diffs to see, well, this is what I've got today, what else is new coming today. So it just makes it just a little bit easier and a little bit simpler to design. Then it logs all the failures, and it's got a bunch of built-in retry mechanisms. And one of the biggest things is that it requests small packets. So if a request fails because the internet has dropped and your request is 100 megs, then it would have to retry that entire request every single time. And the odds are you just might never get those results. So requesting the smallest packets possible so that any kind of failures just result in a quick little retry. So here are the three kind of facility use cases we have. So we have the fully online facilities. So just kind of hospitals, anything that's in like a metropolitan area, generally we can be fully online. That being said, some of those offline systems are still deployed there. So, but the OpenLHIM can then just easily still connect for those systems. Then the more common use case is the intermittently online. So where your internet is spotty, and then obviously there's never online. So there are some places which just are not getting internet and there's no real plans to get internet there. So this is just a little diagram of the kind of architecture. So this is the PHDC, which Pierre spoke about. So the PHDC is the main data center in the Western Cape. So that's where a lot of our lab results are coming from. Then there is the OpenLHIM in the middle. And Matt and Pierre both spoke about that. So that is the Open Health Information Mediator. So that is just transferring all the requests to the right places. Then so the OpenLHIM will then do a request using Fire. And then once the request is successful, there is a bunch of authorization, there's security tokens and that kind of thing to ensure that the request for lab results is coming from a validated facility. Then it will just drop those Fire files onto the file system, and then tier.net has built into it just a little job that runs every so often just to check if there is anything new on the file system, and then we'll pick up all those results and absorb them. Then obviously the opposite way works around as well. When any data is entered into tier will sporadically then put files into the file system, and then the OpenLHIM will just check a specified folder. At the moment, the OpenLHIM is just running a WCF endpoint for configuration. So the two are actually currently bundled together in an installer. And then when tier is fired up, it will, there is some capacity built into it so that it can just communicate via the WCF endpoints to configure the OpenLHIM. So the idea is that the OpenLHIM can potentially be configured for any system really, and it's just given an endpoint, an encryption key, and a bunch of other information about where the OpenLHIM has to get its results from. We've actually recently added just getting straight from the NHLS as well. So I think that's a National Health Laboratory System. So yeah, the idea is that this should be configurable for wherever your endpoints are. So, sorry, here's just a little run through of the workflow. So yeah, so it just runs as a Windows service in the background, wherever the tier.net instance is installed. When there is connectivity, it pulls the API. It receives a manifest file, which basically tells it what it needs to fetch. So again, that's just part of the requesting small packet sizes. The first package you get is just giving you the information of where I need to do my next request. And then each individual request for each patient is done individually. And then it just has a little trickle feed, just getting any data whenever it can, whenever there is internet connectivity. Then it places the documents in the folder structure and then just gets imported by tier. Then tier deals with all the matching of the data on its own. And then, yeah, so this is just to replace the old USB method. So this can still be used in conjunction with the other method. You will find that when these things get implemented, there's the transition period where the new system is not fully integrated and you're still using the old system as a backup. Cool, so this is what we're actually sending around. Fire has been mentioned, so this is the observation resource that we've chosen to use. You'll find with Fire that your mileage may vary. They've made it a pretty extensible format, but everyone has kind of custom data that they want to get. So an observation might not work exactly for your test, and you might opt to go for a diagnostic result. It's just one of those things you just really have to explore the Fire spec and find which the data type is going to work best for you. And then this is what we drop onto the file system. So it's obviously encrypted. So yes, do not just leave patient data lying around in JSON format on your file system. So obviously you just see a bunch of garbage there. That's you need the encryption key, which is shared between tier and the OpenLHIM to read. And then once you've got your unencrypted file, this is basically what the Fire looks like. So this is some dummy patient data that we've got. And yeah, so that's what's going to be shared between the OpenLHIM and tier. And yeah, that's all I have. Is just yeah, OpenLHIM is just a nice idea for a way of sharing data between two systems, which never used to have online capabilities. Cool. So thanks.